Swayam Prabha. Digital India. Educated India.
Welcome to the NPTEL course on Building Energy Systems and Auditing. In the module 4, we are discussing the energy conservation building code. The second lecture of the module 4 is that on the EPF prospective requirement. In the last lecture, we have discussed about the EPF, how to calculate the EPF. Of course, we have taken a very basic shape of the building and all. And today we will discuss, and this lecture particularly will see that how this prospective requirement of the EPF, that is ECBC or ECBC plus or super ECBC compliance, can be taken care of. So, before we go to the particular this compliances, so let us see the last class lecture on the Excel computation, how to do this particular Excel computation. If you remember, the last class we got the value like 69,273. So, let me discuss over it through the Excel. See, in this Excel, you see the facade areas are you have to mention over here, you have to mention the WWR, this is the U values of the wall, U values of the roof, U values of the window, this is the window SHGC, this is the SEF, as of now we are keeping at 1, we will discuss that one, what is how to calculate the SEF equivalent shading factor. So, and the areas are has to give, and based on your table, I mean there are the tables, there are your tables. Suppose this is the EPF coefficient of the composite climate, this is your daytime building factor also, this is your daytime building. First 2 columns are for the daytime, second 2 columns are for your the 24 hours building. So, here you see I have taken that this one, this 6.4 9.58, that one, no, I have taken I think the other one, hot and dry climate 6.4. if I take this one 6.4, which is our case, this is our case. So, if I just copy this one and if I just place over here, paste, then I am getting that 69,243. This compliance and the super ECBC factors has to be given in the green, these 2 columns and the pink columns. So, that we will discuss this lecture today. Let us suppose this is vanished, this is nothing is there, just then let us suppose this is 0 now. So, in this particular thing, suppose now I am changing my orientation. So, orientation changes like this is 200 now, this is 200 and this east and west become 400. I just change the orientation, change the orientation. So, it becomes 70. So, the EPF of the it is little higher, 69 to 70,000 or so, it goes little up. If I suppose increase, suppose if I increase the U value, suppose 2.3 or something like that. So, definitely it will going to increase, this will be 75,000 or so. So, by your if you have your architectural design ready, and if you have north, south, east, west face and roof area, and the WWR is almost ready. So, from that you can do, but unfortunately your orientation always may not be in the east, west or north, south way. So, your orientation of the building is depending upon your plot orientation, your access road and all, front road. So, but ECBC is not prescribing anything on that. So, you have to assume that your building, whatever may be the orientation, with a minimum tilt, which orientation is going to be the recommended orientation of yours. So, that you have to approximately you have to analyze that one. So, maybe you have your building is oriented 15 degree towards north. So, it is better to take the 15 degree instead of other the 75 degree in other way around. So, that way you have to justify your orientations, or which a orientation is mostly your building is oriented. So, that you have to take care. And suppose this particular case I am interested to find out for the this particular building is now maybe located in the cold climate, and that is a 24 hours building. So, I have to crop this part, I have to copy that and I have to paste it over here. So, I will paste over here and I got some new values, it is 88,000 or something in cold climate, but definitely it is a 24 hour building, it is not a. So, like that you just crop the values, you just put the values in the required locations, you change your facade area and all this kind of a thing, you will get your values. So, let us come back to the PPT once again. So, I have just described this thing. So, this you have to calculate as per the architectural drawing I told you, facade areas and the WWR. The next, this whole 1, 2, 3, 4, 5 such the columns has to be filled through the material specification, BOQ, the drawings and all those kind of thing. And finally, this cropping that I have just done now in that Excel sheet, you have to crop based on the ECBC, that particular table, based on the climatic zone and also the building type, which is a 24 hour building or 12 hour building or from that. So, these 3 operations if you do, you can these things will be very easily you can calculate, but you may say that this is a very easy way to finding out, but actual building is very complicated or so. Yes, WWR may change, or you may know only the window dimension. So, directly you can find out the window dimension and see that how much is the facade area, and you can back calculate the WWR and put the WWR values. So, like that we can also see that one, or you can remodify this Excel sheet. This Excel sheet will be sent it to you and you can remodify the Excel sheet and you can compute. So, and finally, you will get the envelope performance factor, right. So, change of the building type we just did, of course, we did for the cold climate. If you have the same climatic zone, so you have to take the other part of the table. The table has 4 columns. First 2 columns are for the daytime C factors and U and C factor SHGC. The third and fourth column are for the 24 hours building. So, I have computed daytime, that what we got is 69,000, and if you same location, the building is same envelope area, same thing, but it is a 24 hours building, your EPF proposed building will be now shoot up to 1,01,676. So, these are EPF points or EPF factors. So, this is a number. So, if somebody comes up with, suppose I am designing in my office, there are I have 3-4 options coming from 3-4 architects, junior architects or something, and now I am calculating those options, 3-4 options. So, I will be actually looking to, from the energy conservation point of view, who can give me the less this value, less amount of the EPF. Less EPF means less heat gain, right, the less heat gain or so, because it has taken care of the compactness, it has taken care of the material, better material, protective material or so. So, okay, there are other kind of the criteria of selection, maybe the functionality, the building bylaws, the aesthetics and all those, that is definitely is there, but from the energy point of view, energy conservation point of view, the less EPF, the best energy conservation, the energy conscious building, right. So, building orientation and the climatic zone is also going to be factors. So, the same building I have repeatedly used for 2 cases, one is longer side and the shorter side is the east west and the north south direction, just we have did it and we got also 70,000 something over there. So, this is the changes. So, every time you see there is a hike, there is a, in case of the east west, if the long side is east west, for all the composite and hot and dry, I think I have a graph also, yes, the graph also. So, you see this is little bit of hike, I think. Let me take the go back. So, it is a it's a hike, it is a little bit of high in case of that is long side, longer sides are east and west. It is this this orange color buildings are these towers are little higher than the blue color one. And if you see the case 1 only, that is, or case 2 only, out of all the hot and dry is the highest 69,000, composite is little low, then the hot and dry, hot and humid is further low, temperate is, and the cold is lowest point. So, that also one you need to see that gradually decreasing the hot and dry to cold, that is the same building if you place it in the cold locations, cold climatic zone with same longer side eastern orientation also, the point will be reduced, right. So, now we have to see the prospective requirement, those 3 type of requirement. So, again let us come down to these 3 particular choices, choice basket. See, the first choice basket is the design development. You cannot change the choice basket because your design is developed. So, your fenestration areas are fixed, your wall surface areas are fixed, your roof areas are fixed, and whatever is fixed. So, you have to take the old values. So, area, the old value area I will take for my new equations for the prescriptive requirement. The climatic data, that means the C factor has to be taken from the old values, because I am not going to change the location. So, what I can only change is the building envelope material to reduce down the EPF value, to target the ECBC or ECBC plus or super ECBC. So, the new values of U factor and the SHGC factor I have to select, I have to go for better material from the energy point of view, and we can actually achieve this performance level. So, table 4.4 to 4.11 of page number 22 to 24 of the ECBC 2017 code is prescribing those values, right, for ECBC and the plus or whatever. So, if you go to the roof assembly, table number 4.4, all the 3 table 4.4, 4.5 and 4.6 are in table page number 22. Table number 4.4 is giving you the ECBC compliant building. So, you have to go with this U factor for the roof. If it is your building is composite, our building is in hot and dry. So, I have to go with the 0.33. So, for ECBC plus, my value will be 0.2. Of course, we have to see one, because my building is not come into this building, because it is office building. So, if it is your school, if it is a school building, then if it is a school building, the cross section, the area of school building is less than 10,000, then you have to take this one. If it is more than 10,000, then you have to take 0.33. So, it is the other type of building. So, you have to take that also into consideration. But in our case, it is all the type of building, because it is the office building also. So, I have to take this one. In this case, it is a kind of the hospitality business. It is I have to take 0.26 or something like that. In case of the ECBC plus. In case of the super ECBC, I told you super ECBC is very strict, and see, you have to have the U value of the roof is 0.2 for everywhere, for all type of building. You see the straightforward 0.2. You have some scope maybe in the other cases, but it is very strict. You remember our ECB, our building we proposed the U factor of the roof as by I think 2.5 or something, but here it is telling that if you want to have the ECBC recommendation, you have to take it down to 0.33 with some insulative material and whatever maybe you have to do, but you have to be 0.33. If you want to be ECBC plus, then it has to be 0.26 further below. If you have to achieve the ECBC, super ECBC, things should be 0.2 further below. So, to more insulative materials or whatever you have to think for your roof, this 2.5 will never going to be give you this particular prescriptive the recommendations or the levels. Now, if you can go to the page number 23, it gives you the wall assembly, recommended values of wall assembly of the 3 criterias. Table 4.7 is for the ECBC, table 4.8 is for the ECBC plus, and 9 is for the super ECBC. So, I am this all type of building, in case I have to have 0.4 U value for the wall, but I think my U value was 1.5, far ahead. In this case, it is super ECBC, I have to go with the business building less than that. So, 0.44, and we see the in case of the U factor, for super ECBC it is straightforward 0.22, right. So, you see this is the if you want to calculate, and the vertical fenestration. The vertical fenestration, there are, instead of the 3 tables, there are 2 tables only prescribed. The first table, table number 4.10, page number 24, gives you the ECBC recommendation, and the table number 4.11 gives you the both ECBC plus and also the super ECBC. Now, here you see there are 2 values, one is the U value and one is the SHGC value. The first line gives you the U value, the first line, both cases, maximum U factor. So, it is hot and dry, and this does not depend upon the type of building, for all building it is the same. So, in my case, the U value should be hot and dry. So, it is 3 recommended maximum, but my case it is 0.75, far less, right. So, that is good. SHGCs are given in these 4 rows. Now, here the first row, the maximum SHGC non-north means the south, east and west. So, that is recommended is 0.27 hot and dry, but in the north there are these last two rows are for the north. This is also for the north and this is also for the north. Now, you have to see the latitude, where is your building is located. Is it in Delhi? Delhi is your more than 15 degree north, or it is in somewhere in the down south in the hot and dry climate, maybe somewhere there, maybe the central part of the Tamil Nadu or something, then it is less than 15 degree north. So, based on that you have to choose. So, if I say it is Delhi or somewhere, I have to take 0.5, and if I say it is somewhere in the central part of the Tamil Nadu, then it is 0.27 I have to take. Similarly, the 4 lines are also mentioned over here in the case of the ECBC plus and the super ECBC, and these things are furthermore. So, it is 3, it is 2.2, it is 0.27, this is 0.25, this is 0.5, it is remained same, this is 0.25. So, let us see the calculation for my last calculation which we did in the last lecture, if you remember. So, I have calculated for ECBC compliance and the super ECBC, the central one ECBC plus I have not done because things are same. So, in case of the roof, if you remember that my roof was 1250, no change I told you. In case of the area point of view, there should not be any change, design development. There should not be any change from the C factor, if you remember in the last lecture, or you can go through your the last lecture video. You can see the C factor for the roof was 14.82 based on the hot and dry climate and 12 hours building. So, no change. So, I should write here no change, no change. Only change was this U factor, which was I think it was 2.5 or something, I did not remember. You can go back and you can see, or 1.5 probably out of 1, and this new value has to be taken from the table number whatever 4.4 is this, and this is 0.33, I have taken this one, yes. And in case of the super SCVC, this remains same, no change, 1250 area of the roof remains same, no change, only this is the new value. Which was is the new value? This is 0.2. So, in case of if I want to find out the ECVC plus, I could have been, I have taken 0.26 then. So, I have another row, another number. So, if I want to achieve the ECVC building, so my EPF roof should be around 6100 something, and if you want to achieve super ECVC should be 3700 and something 5. Similarly, I have computed for the mass wall, no change, 6.4 is the C factor for the wall. If you remember, 960 was the area of the wall, if you remember, so no change, and this 0.4 is the change new value, which is comes from here, and 0.22 is the new value for the super ECVC. So, I got those two big numbers for the EPF of the wall. First one is for the ECVC compliant and the second one is the super ECVC. Let us go to the next. This is for my vertical fenestration. In the vertical fenestration, I have to recompute. So, this is your C1 factor, if you remember, minus 0.37 C1 factor. So, no change. The areas are AW, also no change. Only what we have changed this particular U value. Recommended U value is 3, hot and dry. So, I put the 3, red color one is the change value. Similarly, this is the C2, 101, 252, if you remember, it is also no change. The areas, this is AW, no change. Only change in this, let us discuss this one. This is north. So, north is the last two line. So, my building is above 15 degrees. So, my will be this one, not this one, and this is my value. Okay, these last three lines are for the SHGC. Okay, so, out of that north one is last two and one is this first one, the third line is for the latitude more than 15 degree. So, this is that. Let me give the arrow. The south, east and west are 0.27, 0.27, 0.27. Why? Because they are non-north. They are not north, they are non-north. So, non-north value is this 0.27, yes, non-north, SHGC for the non-north. So, this is for south, east and west. So, that comes here, that comes here, okay. This one and this 0.27, and I multiplied, add up, and then this is my values for, but please remember this is for the ECVC compliant. Similarly, I have recalculated this thing for the ECVC, super ECVC cases also, where these are the no change cases, these are the no change cases, I am not writing, and this red color were the new values. So, new value of the U value is taken into account. This 0.5 is the new value of the non-north, of course, for the latitude more than 15 degree north, and 0.25 is the maximum values of this one, south, east and west. Recalculated, it is coming around 13,141, earlier one is 13,700, little higher. Now, I will add those values, and you see my proposed one, which was we have discussed in the last class, was 69,000, which is this proposed. if I want to achieve the ECBC compliant building, ECBC building, then it should have been 22,000 only. It should be, we have to put it down. Somehow we have to insulate the building. If we want to achieve a super ECBC, it is further below 18,000. In between there may be a ECBC, in between there will be your, in between I have not calculated, it will be ECBC plus. It may be in between 22,000 and 18,000, maybe 20,000 or something. So, if you have to further below, if you are make more insulation or something like that, then you can actually get the super ECBC. So, these values are your guiding values, but why it is called trade off? Because you can put, suppose you do very insulative material, you proposed very high insulative material for your roof, and that brought down the roof EPF value too much, and you can have little bit more in the fenestration on all in the wall. So, that kind of that is known as the trade off kind of a scenarios also that we can do. So, I have calculated for this something like which we discussed, longer side north and south and the longer side east and west, and proposed values. So, all cases you see this green tall buildings or the tall birds are your proposed values for all these 5 climatic zone, and the purple ones are your ECBC compliant, which is very low, and red ones are the ECBC super ECBC, which is further low. So, and you can see that how much insulation is required for all the climatic zone to reduce down your green bars to similar to your the purple bar or maybe the red color bar. So, the equivalent shading factor ACF, that also we can calculate. We will introduce this thing in today's lecture and we will discuss it widely in the next lecture. So, a building may have a shading device, overhang something, overhang or maybe the fence, and based on that particular geometrical this shading devices, there we can calculate some benefit we can get in the EPF. So, in this we can find out the vertical depth from the sill level to the bottom of the overhang. So, from the sill level to the bottom of the overhang. Okay. So, if the overhang is your chhajja or the sunshade is here, so this will be your actually V. Okay. So, I have just taken it little bit away above. So, it is your V, and this is your H, the projection, how much is your horizontal projections. This H and V will actually decide the sun angle, or that how much shading it will be provided over your window. So, we decide, we call that is a projection factor, the PF is H by V, right, projection factor is H by V, and so as per my design I can find out that how much is the projection factor H by V, and based on this projection factor I can find out this ACF, that shading equivalent factor, which will reduce my SHGC value. If you go to our earlier the equation, of course, we will discuss it little further in the next lecture. The equation given for to find out this the ACF is the C3 into PF to the power 3, C2 into PF to the power square or PF square, sorry, and C1 into PF is your projection factor plus C naught. So, this C3, C2, C1 and C naught, again there are some tables, from there you have to take, at that depends upon the latitude over or below that 15 degree north, that criteria, and the facade orientation like north, east, west, northeast and all. So, these are the two such tables. First table, the table number 4.12 is for the latitude equal to or greater than 15 degree, and the second table is for the latitude less than 15 degree. So, suppose those are the overhang. So, for overhang my values are this. Suppose my the window are in the east. So, C1, C2, C3, C4 or C0 are those these 4 values. So, that has to be taken into the earlier equation. So, those values has to be put over here, and PF I know from this. So, I will see this and then finally compute the what is the ACF, and ACF is always greater than 1, will be greater than 1, and that will give some kind of reduction in the SHGC value. So, here what we did, we discussed about the prospective requirement, 4 type of requirement. One is in general the benchmarking the building, normal building, and the 3 of course, the 3 levels, not 4 as such, but 4 times you may have to compute. One is for the typical building, and ECBC compliance, ECBC plus compliance or super ECBC compliance. So, by virtue of those tables given in the code, and by virtue of only changing the central part is the material specification part or so, the rest 2 part will be remain constant. Thank you very much.